This is a video on a hypothesis test for a paired difference. The question states, are average SAT math scores higher the second time students take the exam? The results from 9 randomly selected students who took the exam twice were tabulated. Use alpha equals 0.05. So here's our data. We can see our data from the first try and our data from the second try. It's 9 different students that took it twice. So we need to come up with a null and alternative hypothesis for this question. Notice we're talking about hypothesis test because we're asking, are SAT math scores higher the second time? We're not approximating a difference. So we have an H naught, and because we're looking at a paired difference, so we have the same person taking it twice, we're talking about a mean difference. So we write mu sub d is equal to 0. So we need to find the alternative hypothesis. Well, we want to find out if they're higher the second time. So in particular, and this is a little tricky, if they're the higher the second time and you subtract 490 minus 520, for example, because that would be higher the second time, you get a negative number. So HA, the alternative hypothesis, colon, is the population mean difference, mu sub d, is less than 0. Because if they're higher the second time, then the first minus the second will be negative. So now we're ready to go to our calculator. Here's the calculator, and we're trying to do a hypothesis test for a difference, and the data is paired because it's the same person taking the test twice. So I scroll down until I find 2 dependent samples with data. Dependent means paired, and we have data. So I click that, and it asks us to put in the data separated by commas. So I do that. So here's my list of the first data set separated by commas, and here's my list of the second data set separated by commas. And we wanted to set our alternative hypothesis to be that mu sub d was less than 0. So we click on less than. We're doing a hypothesis test, so I don't care about the CL, confidence level. And I just hit calculate. And there we have it. The test statistic, T, is equal to negative 1.928, etc. And P, the p-value, is equal to 0.04, etc., etc. We're not finding a confidence interval, so don't worry about the lower bound and upper bound. And in case you're interested, these are the data diff. In other words, if you subtract the first data set minus the second data set, these are the values you would get. But what really matters is the test statistic and the p-value. So now let's interpret them. So our test statistic was t equals negative 1.93, and the p-value was 0.0449, etc. Notice that our level of significance alpha is 0.05, and 0.0449 is less than 0.05. So that means I get to reject the null hypothesis. So let's state our conclusion. We can conclude that there is statistically significant evidence to conclude that the population mean SAT exam score is larger on the second try than on the first try. And I'm done with the problem. Thank you for watching this video.